Hi guys, I'm going to take you through today just an update on the power supply. I'll show you guys the two OPA 2244s that I've actually put onto the little proto boards from Oshpark, and how I've built them into the circuit. I've used only 5% resistors throughout, so I'm not expecting this thing to be accurate at all actually. But the idea was just to test the basic operation, make sure everything's fine, everything's working. I'll show you that, how we can regulate the voltage, how we can regulate the current. I've written a quick little just app that I'm running off my Yun, off the HTML web browser. Sorry, not web browser, web server on the Yun, just to simply control it. I've just used the Yun for this one because it provided a quick and easy, nice interface to do that without building much. I'll show you guys how that's working, and using a standard ATX power supply, which is the reason I'm trying to build an actual lab power supply so that I can have something that's settable. Yeah, so have a look. Let's get going, and I'll take you through it. So here we have the whole setup. As I said, what we're doing. Here's our two op amps that we trying to use. I've just put them onto those little expander proto boards that I told you that I got from Adafruit. So there I've put all the shunt resistors. These are just a whole lot of 10 ohm resistors in parallel. They all together come to about 1 ohm. Now that's obviously a little higher than what will be in the production version of the power supply, but just wanted to test the general functionality and make sure everything works. So they go through the first stage. Op amp down here is a 10 times buffer amplifier. Top one I think is another 10 times amplifier, and then we have our current monitor and our voltage monitor. So what you'll see is our voltage set is through that cable, and that's connected to our Yun on digital pin 5, which is a PWM channel, and similarly channel 6 does our current limiting from the Yun, also a pulse width modulation signal. One of the inputs to our current limiting transistor here should go back into the board, but what I've done is I've just connected that up to a little LED, just so that we can easily and quickly visualize what's happening. So that simply powers from 5 volt. So what I've done is the top breadboard here I've broken into, that's a 5 volt supply. We've got a common ground. The bottom one is a 12 volt supply coming from a stock standard ATS power supply. You'll see what I've done is the green line here goes into the 12 volt power rails for the bottom board. Yellow on an ATX, as you must know, is always 12 volt. Red is always 5 volt. Orange down here is 3.3 volt lines, etc. Right, and black is our common ground. So what I've done with the one black cable goes into our board common ground. You'll see there they are actually connected, bridged over. The ground is bridged over, but the power lines are separate. You'll see there's no bridge to bridge our power line. So top one is 5 volt, bottom one is 12 volt, and all I've done is I've hooked my multimeter into the common ground as well, so that I can just use the one probe to probe around all over the place. Right, so that's the setup. Let's power this guy on, and you'll see what I'm doing with the standard ATX. So this is why I'm building a power supply, right? Because ATX power supply is just a bit crap if you want to do actual lab work. So I made a simple little jumper, and what I'm going to do is jump over the green and a ground pin, and as soon as you do that, everything powers on. Fans going, yes. You'll see the little LEDs on our Yun. We've got the green LED, I hope you can see that in the camera. Green LEDs going, and now we just need to wait for the Yun to power on. Okay, so now that our little white LED is on, we know the Wi-Fi is up and running, everything's fine. One thing I forgot to mention is I'm running the UN from the 5V supply into the voltage, or the V-in pin. On the UNs, the V-in is 5V only. It does not have a grade regulator on board. So okay, that's 5V in. And now that the Wi-Fi is up and running, okay, and there you can see a little interface that I wrote for the UN. And all it is doing, I've got a little picture of the UN. I'm not done with it because I still need the analog pins there to read the analog data. But what you'll see is, as soon as it's powered up, you'll see what the different pins are toggled to at the moment. And I've simply marked each pin down the side there, and the idea is to connect them to the actual pins on the board, picture the board there. And just to demonstrate how this works is, if we watch the little red LED, which is currently connected to, which is always connected to pin 13. If I toggle pin 13, there we go, it turns off, right? So and ideally the little one in the screen here, the one in the screen there should move to 0. And similarly, if I toggle it on again, it'll come on. So that's the idea. So the reason I wrote this quickly is just so that it's an easy way for me to test the analog inputs for my board. So in the final design, I'm not planning to put a UN on the board. I am planning to put a nano on the board as our main controller. But as you can see here, if you want to add some other functionality, or if you want to do something else interesting with it, you should be able to quite easily just break out the pins, connect them into the same pins on the top controller board of our power supply, and use any other controller you feel like using. Right, so let's get going with the testing. I'm going to turn a quick couple of tests. If we look down here, that's going to be a 12V supply being fed basically straight through. The only drop is through our shunt resistors. So through the shunt resistors, straight through here, just to provide a bit of a volt drop on there. So as well as you'll see the so I'm not actually controlling this voltage at this point. The only thing this voltage is doing is providing a bit of a load for the power supply, just to keep it going. This is one of the older ATX power supplies. But the interesting pin is this pin over here. These little guys here is the output voltage that is actually sent to our LT3080, the linear voltage regulators. Now obviously, as you can see now, we've got just under 12V coming in. So with these 5% resistors throughout, etc., I'm getting 9.6V to the output if everything is on. So what we'll do is I will toggle our voltage, I think. Let's toggle that. And if I turn, let's not do that. So let's go for the analog controls. So if I go 254, oops, not 1254, 254, and I go up one, that turns that we've now turned D5 pulse width modulation full on. And let's do the same for D6. Let's go to 54. If we toggle that up to 255. So what you'll see now is we've got maximum voltage, maximum current. If I drop this current to, let's say, half that, let's go for 128, and I drop it up, you'll see our current limit LED turns on immediately, because we've dropped the current, and you'll see our voltage also drops because it is trying to current limit this little guy. And the only way to current limit is to drop the voltage, right? So that's effectively what will be pushed through to our LT3080s. which will therefore control the current nicely. So if we push, let's push our current limit back up to the full value, 255, right, turns back off because we're not limiting the current anymore. And if I now step down, what you'll see is that our little LED starts to slowly turn on as the voltage comes down as well. In the final version of the power supply, this LED will be driven from the microcontroller directly. So I'd like to, I don't know if I like the idea that it comes on dimly and slowly comes on, because you might not notice that you're in a current limiting state. So the idea there is that from the microcontroller, the moment you go into any kind of current limiting, it'll come on. I might, yeah, I need to think of a way to do that nicely, because, well, you'll be able to see the voltage and the current at all times on the power supply's display, so you'll know that when this guy comes on, that's why you can't get your voltage all the way where you set it, because it's in current limiting mode, etc. So okay, let's pop him back up to our full value. If I can stop moving the screen and just toggle a little button, right? So there's our max value. So our current, let's leave our current limit on. So current limit on, and I'm going to start reducing the voltage just to show you that that works. And you'll see it count down in roughly about 2-ish millivolt. Sorry, 20 millivolts at a time. And that we can keep going. Right. Now, I mean, just to show you that you can actually set the voltage quite nicely. If we set this guy to, let's see, 3.3 volts, I tested this earlier, not really well calibrated, but just to show you the idea. 3.3 volts, if I set this guy to 81, oops, not 80, let's go for 81, go, and you'll see 3.3 volt on the display. So the final solution should obviously be calibrated to that. Let's go for 5 volt. 5 volt I've worked out is 127. Right, 5 volt, and we've got 5 volts on our display. And similarly, if we want 9 volt in this case, I just picked a random another voltage to show that we can actually set it. 244. Almost. Alright, that's 9.5 today. Thanks to our 5% resistors. But we should be able to bring that down to where it's supposed to be. Right. And 8.9, 8.98, 9.02. So yeah, that one is better. So 235. So the idea there is just to show you that we can actually set the voltages carefully. The current limits work and everything is good. So yeah, that's basically what I wanted to show you guys today. Obviously this is the second phase of the power supply. We're now getting to the point where we need to start testing or assembling our first stage of our board. There's our initial boards that came back from Osh Park. I can't say there's enough. Osh Park, use them, really cool. I did make one mistake on this board that you might notice is right over there. I had one trace, the trace coming from there actually bridging over to this. So as I've said before, this board is intended to allow you to either use surface mount caps or through-hole caps, whichever way you want to do it. But connecting that trace to that trace, because they are the components are completely overlaid like that, I couldn't run the check in Eagle, and therefore I I missed that little item. So in the production version, that trace is moved to over there and all's good. But for this version, I just made that little cut with a little scalpel and problem solved. So yeah, so this is the next step now, is to solder in all our bits and our capacitors. We're using through holes for the first version just because it's cheaper and simpler. And then we'll start testing this board, and I'll take you guys through that when I get to that point as well. Right. Well, with that, if you like this video, let me know. Give it a big thumbs up. Tell your friends, tell your family, as usual. Otherwise, see you guys on the other side. Cheers.